Hi everyone, I'm Daniela. I work as a PhD candidate in Leiden in the Netherlands, and I invited to speak or talk about reproducible research with R. We called it From Raw Data to Results to sort of mirror what Kevin talked about before, where he sort of summarized the entire research life cycle. And I would like to focus on what researchers can do to make their workflows more reproducible and how R can help with that. But let me first introduce myself with this slide. So if I don't work in computer science on my PhD, I hang out in gardens. And sometimes I have chickens on my arm. This chick is called Frank, by the way, just, yeah, because we like the name Frank for a chicken. If I had to give myself a few keywords, then that would be the keywords. I'm working with multimodal data. I'm trying to integrate data from different data sources into useful and surprising information. Well, yeah, we're working on it. It's research. I stumbled into open science and reproducible science during my PhD, or at the beginning of my PhD. So this is kind of now becoming sort of part of my PhD project almost. I work with minimum description length. That's something well, physicists, if there are physicists in the audience, they might notice we're using that compression principle to find patterns in data. That's the very short form of my work. And one of my favorite topics to talk about, apart from reproducible research, is ethics in data science and where it goes wrong, which I'm not presenting on today, but which I'm very happy to chat about. But I do want to know who you are. So I made a Menti, and now comes the moment where I switch between slides or windows. So if everything is good, you can now see the Mentimeter should be open. And I just make this a little bigger. And I can share the direct link to the Menti in the chat as well. So this is a check if people are still online and active, and to see how many people are active. I hope this works. Please tell me in the chat if it's not working. I read, what is WISMA? Is that wissenschaftlicher Mitarbeiter? Probably. So we have lots of research data management support. So I'm guessing that these are all people working at the library. Research scientists, assistants, lots of support staff. So I'm asking this mainly to know if people are more from the library or more like researchers. So that was my main question. Let's look at this for another few seconds, and then we can close it and go to the next question. Survey methodologist, that's a cool one. All right, let's close this one and go to the next one. I think if I just click next, you should be able to answer this question. So what I did is I I found these three, I pasted these three hex stickers there. And now my question is, which one of those logos do you recognize? And you can choose more than one. So the first one is from Reaper Hack, the second one is the Turing Way, and the third one is our Markdown. And that will give me a bit of an idea of how much I'll focus on these sub topics of my talk. Okay, lots of R Markdown, that's good. That's great to see. So I will not lose too much time on Markdown, I guess. I will definitely talk about the Turing Way, and I'll close the session, I guess, right now. I think voting closed, and I want to start this presentation with Reaper Hack and what Reaper Hack is. Then I'll talk about very common challenges or common issues that people encounter when reproducing other people's results. And then I'm going to talk about how R can help you overcome these issues. And yeah, so that will be sort of my presentation. And so let me start with talking about Reaper Hack. And I saw that some of you actually knew what Reaper Hack is about. For me, Reaper Hack started with a huge frustration, which was that I could not get a baseline algorithm to work. It's a baseline algorithm that I wanted to compare my own work to. And then what you do, you run some data set and with the baseline algorithm and with your own algorithm, and then you show that you're hopefully better in some sort of way. Problem is, if you can't get your baseline algorithm to work, you have nothing to compare your work to. And that was extremely frustrating because I didn't know which version of MATLAB I had to use, which packages within MATLAB I had to use. The entire code was like a combination of MATLAB code and Python code. It was a huge mess. And I thought, if I cannot even get that to work, I should not even start like working on my PhD. So huge frustration on my side. Comes along a few people that are thinking about, that were busy with reproducible research. And one of them, Anna Cristoli, had the idea of doing repro hacks. What are repro hacks? Repro hacks are events where authors can submit their work to. So they submit their article or results. It can also be a preprint, along with associated data and code. And then the participants at the repro hack basically give feedback on how reproducible the results are. And the situation is like a win-win here, because the authors get feedback on their efforts of making their work reproducible and reusable, and the participants get to have this hands-on experience of working with someone else's hopefully reproducible code and work. So I want to very quickly mention the people that are working, that we're working together. So Anna Cristoli, Florencia, Linda, and Paloma, and there are many more. So whenever a repro hack is organized, there are local people, obviously, who are doing the work of organizing it, and we might be sort of supporting them. We're doing lots on Twitter, these kinds of things. And one of the last repro hacks was actually this one in Rostock. which was organized together with the Thüringen Research Forschungsdatenmanagement team. And the cool thing about the Rostock one was that they actually had 3 levels of participation. So you could start with taking code and data and reproducing results, just very straightforward, basically running code on the given data, getting the results. Or you could go like level 1 up and translate the data, the code from one language into another. So from Python to R, I think it was, or from Python to Julia, which is also an exercise of reproducing someone's work. But it goes further, right? It goes like beyond just running someone's code. And then there was also the possibility of joining a team that containerized the computational environment for that project. And I think it was a success. But we can, I don't know if anyone, was there anyone at the Rostock Repro Hack? You can maybe tell us in the chat if it was cool or not, what you liked about it. Or we can talk about it.
I was there.
Oh, Kevin, you were there, right?
Yeah, I was one who also organized this event with Rostock. And yeah, it was quite nice. The second group you mentioned, we transformed it from R code to Python, or also one person to Julia. And we were successful. So at the end, we had it in different languages and we could reproduce the R code. And if I can say here, we also, so it was good code, very good code. But we had small problems, like there were, for example, magic numbers inside. So they were not explained, or which libraries you need to that the code is working. And so we had small problems, but at all, it was very good code. Yes.
Yeah, cool. Yeah, this is, but it's very often that you have to really deep dive into code to realize that there's this one hard-coded figure, or this hard-coded number that somewhere in the process you hard-coded it and then you never thought about it again. So this is why Repro Hacks kind of help also the authors improve their work. And so from different Repro Hacks, not only the ones in Rostock, but we had several online ones before that, and we had bigger ones, one in Leiden in the Netherlands, and then several ones in the UK. There are like common challenges and issues, and these 3 I picked because they are, in my view, the most common ones. One is raw data availability. The second one is the documentation of the data and the code, and the documentation about the computational environment. So computational environment in the sense of which packages are you using, which operating system are you using, which software version you're using. Why are these things a problem? In my point of view, the raw data availability, and more specifically, how you get from the raw data to the data that you're then using as a basis for your analysis, needs to be transparent, because you need to know how you got the data that you're actually working with in the end. In these pre-processing steps, you make a lot of decisions. So you make the decisions of which data are you throwing away because it's not complete, for example. So I work with sensors, movement sensors. There's lots of filtering happening. Why are you setting this one filter and not the other one? Why are you setting thresholds the way you're setting thresholds? All of these decisions need to be written down somewhere. Ideally, you just put them into your pre-processing code, because then everyone can actually see what's happening. Plus, you don't need to write a bunch of text in your paper. So how did you get there? And what I find also important is that to be aware that these pre-processing steps can actually sort of propagate through your entire analysis. So you make a decision at the beginning, and this decision can influence your results at the end. So that's this propagation. So yeah, you want to be careful with your pre-processing, and you need to know where you're coming from. And then we have documentation of data and code. I put down this question, where's the code in the repo? So this is when you go through a journal article and you find a figure, or you find a table, and you want to then know, how did they get to that figure, and how did they get to that one number in the table? And then you open a repository, or you open the zip file with all of the scripts and the data, and you don't know where to start. So this is what I mean with the documentation of data and code. So the link between the data, the link between the paper, so the results, and the data and code. Where do I find the code and the data that is associated with figure number 2? That's what I meant here. And this is something that very often comes up, that participants just don't know where to start. And then documentation about the computational environment. That's exactly the frustration that brought me up, or that got me to join this Repro Hack team. Which package did you use? Is it deprecated or not? Which version of R did you use? Is it Python 2 or Python 3 code? These kinds of things you kind of want to tell the user of your repository beforehand. Before I talk a little bit about how R can help with these issues, a little disclaimer, which is R is not a necessary requirement for reproducible research. There are other coding languages. There's Julia, there's Python. In the end, you could even work reproducibly with SPSS if you noted down everything that people need to run redo your analysis in SPSS. So this is the disclaimer, basically, that R is not the only answer to these reproducibility issues. Also, you will see that many of the two suggestions that I bring, they also exist for Python, for example, and they can easily be translated into other computational tools. So I thought we can talk about two things that are useful to counter or to counter these issues. The first one is compendium style organizations. I realized that someone else was talking about research compendia before this week, so I'll reiterate probably what Daniel said. Daniel Nüst, I think, talked about compendium style organizations, if I'm not completely mistaken, or at least he mentioned them. And then I want to talk a little bit about R Markdown for reports and papers and how I use them. So compendia. Behind the idea of research compendia is that the article is just the advertisement, but that data and code and the analysis to get to these results that you're advertising, that's the actual research product. And generally, we want our research to have impact, and we want other people to use our research and to use our research product. So what we should do is to present the entire research product in a way that other people can use them. And a good way to do that is a research compendium. I want to, this is a minimum research compendium. So you see it's basically a folder. You can also call it a repository, where you have two files in there. One is a description file where you store all the project metadata and the dependencies of your computational environment or your software. Then you have a README file. The README file guides the user through your folder. And then you have two folders, it guides the user through your compendium. And then you have two folders in there, one for data and one for analysis. In the data folder, you find, well, the data. Ideally, you have one raw data file and one data file that is like a pre-processed data file. And then you have an analysis folder with your scripts. This is a very minimal structure. And if you are just getting started with R or generally with making your research more reproducible, I strongly recommend working with the minimum compendium and then slowly building on top of that. A version of this minimum compendium is this one, where they added a license. So that is important for the reuse of your work. And in the analysis, they have a RMD, so an R Markdown file instead of a script. Again, this is a very minimum version of a research compendium. As your project grows, this compendium will grow. So now is the time where I will share an example compendium from my laptop, which I opened yesterday. For context, I'm working with simulated data. I'm developing machine learning algorithms. I'm simulating data. It's a mess. That's my summary, and you will see in a moment why I think it's a mess. So here we go. This is the moment of truth. This is the sort of the hashtag no filter version of my research project, and this many of these folders and also documents, MD files, were generated automatically because I made a project, a package out of my research project. So for example, the license, the conduct file, the contribution file, these are all automatically generated when I use the RR tools package to make a package, R package out of my project. So what else do we see? We have a tests folder. I studied statistics. I work in computer science. I only started testing my code last year. That's the bitter truth. I'm not proud of it, but to be honest, I don't know how many of my colleagues are testing their code. You can start asking your colleagues if they test your code and if they test their code. I'm not sure how many people actually testing code. We all should test code, by the way, but that's another topic. So I have a folder that is called inst. I have no clue what's in there. I haven't had a look at this project for like 3 months. So there's a description file. There's a folder with analyses. Then a bunch of RMDs and HTMLs, which are my R Markdown files for intermediate reports. So when I work on stuff, I put code into. I use these R Markdown files to generate intermediate reports that I can then share with my supervisor. I don't know, not necessarily the best way to organize this, because it's like randomly in there. Also a results PDF that somehow ended up there. I have to clean this up, definitely. The MAN, that's the documentation in R for the R package. I have a manuscript folder and an R folder for all of my scripts. Let's look at my data or the analysis. So within the analysis folder, I have figures, templates, a paper folder technically, and the data. Within the data structure, I have derived data and raw data. This is for my case study where I'm actually working with external data. And then I have a bunch of RDS files that until yesterday, I wasn't really sure where I saved them. Now I know that I saved them there. It's a good location. It's the data folder. And those are all simulated data or results data from my simulations. So what I'm thinking I should do is add a folder here that says simulated data. So simulated _ data. I do like that there is this one empty file here that says do not edit any files in here by hand. This is automatically generated from when you use that RR tool. I like that because it reminds you to not touch your data by hand. And finally, my .r folder, or my R folder with all my scripts. This is because I'm working with I'm writing my own algorithm, my own packaging. Someone who say does one correlational analysis and maybe a t-test would get away with one script or an R markdown file. I have no clue what this R markdown file does in here. So again, this is no filter. This is very honest from what I found on my laptop. I hope you're not super disillusioned about how researchers work. I'm not sure if any of you that are actually working as scientists or PhD candidates, for example, recognize this from your own laptops. But yeah, so I wanted to share this to give you an honest view on how stuff is working. There is a lot of info online. I mentioned RR Tools. RR Tools is the R package that automatically generates all of this packaging or package environment for you. It's basically a template that you then fill with your own work. The first link is a tutorial by Anna Cristalli on how to use this tool. The second one is a paper that introduces this tool. Then the Turing Way. The Turing Way is an online book that is written by a bunch of people together. And I highly recommend it as the first stop for information about reproducibility. Just whenever you have a question about transparent science, reproducible science, or open science, check if there isn't a Turing Way chapter on it, because this will get you up to date very quickly and gives you a very good overview. So I highly recommend the Turing Way. It's a collaborative document. They run ride-along sessions every so often. Yeah, follow them on Twitter. It's a really, really cool organization, or a really cool cooperation. And then the last link is Research Compendium Science, which is basically another collection of information about research compendia, also in different fields of research, and how to use them. Now, the second point, or the second tool that is easily accessible, is linking code and results. So what I mentioned before is that oftentimes participants at Repro Hack would read a paper, a results section, and then would want to say, start working on figure 2 because they were intrigued by this figure and said, okay, we want to reproduce the results here. But then they open something like this, so a repository that is like full of stuff. And if you wanted to find figure number 2 in here, I'm guessing it's somewhere in some RMD file, but I wouldn't know myself where to start. So it's important to be able to link the results section of your paper and the code, the analyses, the right script, basically. You can do so by writing a good readme.txt or MD. This definitely, if again, if you're starting with using R, if you're doing very simple analyses, and I'm not saying that simple is bad. Most of the time, simple is what we want. So if you're doing like a correlation analysis or a t-test, something very standard, you can get away with writing a README file where you say figure number 1 can be found in the R Markdown file named so-and-so, or in script named so-and-so, and table number 1 can be found in this and that script. That definitely, when it's like a more basic analysis, is enough. So there's no need to dive into R Markdown. If, however, you want to produce a fully reproducible paper and make it even easier for the user, and also I feel if you using R Markdown for your paper can actually convince peer reviewers much more, because they can then immediately see that the scatter plot is not hand drawn, basically. I don't know. I feel that it's like even more evidence that your research results are cool. Then why not have a look at R Markdown? Something that I only discovered about a year and a half ago is that in our studio you can you find lots of templates for R Markdowns. For example, if you wanted to publish in PLOS or in a Frontiers journal, you would have those. There's also from the, I just saw it this morning actually, the ACM, American Computing Machinery, Society for Computing Machinery, which is the template for computer science papers, for example. So you basically have templates to write documents where in this document you can put the text of your paper, but also automatically generate the figures and tables that go along with the text. And that's really sweet. And that's really sweet because then you can automatically link the code and the results. This is how an example would look like if you had code and the results. It's not a very nice scatter plot. I'm completely aware of that. But say you had somewhere in your report that scatter plot, someone else could easily find out that, well, I used a ggplot, and this is the data I used to generate that plot. And then you only have to know where all info Lisa is from and all info Gida is from. Yeah, to be honest, I have to work on the naming conventions in this project. But technically, you should be able to find the data. So this is why I like R Markdown. Now, a few sort of concluding remarks. Take little steps. Reproducible research is not easy. Usually you're not learning that during your master's. You're not learning it at graduate school, or at least in our system here in the Netherlands, you're not really taught this. So one question that you can ask yourself is, where is your raw data right now? So you could start with just like reflecting on where is it? Is it at a location that is okay with having your raw data? And where is your pre-processing file that got you from your raw data to the pre-processed data? What you can also do is set up a compendium style folder structure. So even if you are not working with R, you can always use this folder structure to organize your work. And what you could also do is get your hands dirty and write a README file. I'm pretty sure that there's at least one research project folder on your laptop that doesn't have a README file. So try writing one, and then show it to your colleague and ask them what they think about it. So this would be like 3 little steps that you can take right now, tonight, or next week. Maybe not on a Friday night, next week. To start next week. Yeah, don't do it Friday evenings. And very final remarks is, reproducible research is difficult. R can help you along the way. I want to reiterate that R is not a prerequisite for reproducible research. There are other tools out there that can make your work reproducible. And start small, start with the little steps. Ideally, you find a community of learners around you in your institute, at your university, people that started a PhD with you in the same year. And then you can grow together. And if you like, as a community of learners, you can also organize a repro hack. And I'd be more than happy to help you organize one. These are my contact details if you want to contact me or contact repro hack. Best thing about repro hack, like best contact point for repro hack, is just Twitter. And that's it.